In this video, we're going to solve this coding interview question, single number. In this problem, given a non-empty array of integers nums. In this array, every element appears twice except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. This is the problem statement. In this problem, we are given an array of integers, and in that array, we have every element appears twice except one, and we have to find out the single one. In this example, we are given this array. In this array, we see 2 appears twice and 1 appears once, so we have to return 1. In this example, we see 1 appears twice, 2 appear twice, but 4 appears once, so we have to return 4. And for these examples, we have only one element. This element appears once, so we have to return this element. Now, how to solve this problem? We have a constraint. We have to solve this problem in linear runtime complexity, and our algorithm should work in constant space. First, let's talk about the brute force solution. In the brute force solution, what I will do, first I will construct a set data structure. Let's assume this is our set data structure. In this set data structure, I will store the non-repetitive elements. That means the element that appears only once. But how we're going to do that? First thing, we have to traverse this array from left to right. First, we have 4. We see 4 does not exist, so let's insert here 4. Now we have 1. 1 does not exist in our set, so let's insert here 1. Now 2 does not exist, so let's insert 2 in our set. Now we have 1. We see 1 exists in our hash set, so what I will do, I will just remove 1. Now we have the element 2. We see 2 appears in this set, 2 exists, so we will remove this 2. So let's remove this 2. Now we see that we have only one element in our set, and this is the single element. This element appears only once in the given array, so we have to return this element. This is how we can solve this problem using hash set data structure. Now let's implement this algorithm. Now let's implement the brute force algorithm. First thing, what we're going to do, we're going to check if the length of the array is 1. It means that if we have only one element in the array, we should return that element. So return nums 0. Now let's create a hash set data structure. So set will store integer. Let's call it set equals to new hash set. Now we have to iterate the array from left to right. So for int I equals to 0, I less than nums dot length I plus plus. Inside here, we're gonna check if the current element contains in our set, then we'll remove the current element from set. So let's check it. Set dot contains, if the current element contains in our set, so nums I is our current element. If our current element contains in the set, then we'll remove from set. So set dot remove nums I. Otherwise, if the element does not exist in our set, we will add the element to our set. So set dot add nums I. When we're done with this for loop, we will have only one element in our set, so we can return that element. For that, I have to use this statement, set dot iterator dot next. We have to iterate over the set. If we iterate over the set, we will get all the elements exist in the set. We have only one element in the set for sure, so we can just return set.iterator.next. This algorithm will take O of in time complexity and O of in space complexity. Now let's run this code. Accepted. Now let's submit it. We have successfully solved this problem, but this is a brute force algorithm. We have a constraint to this problem. We have to solve this problem in constant space complexity. Can you solve this problem in constant space complexity? Now let's see how to improve this space complexity to constant space complexity. Let's assume we're given this array of integers. In order to solve this problem in constant space complexity, we have to use XOR operator. We know for sure in the array we have some element appears twice and only one element appears once. So we can use XOR operator. We know the XOR operation for two same bits, it results in 0. If we have two number A XOR A, it results in 0. If we apply XOR operation in between two same number, it will result in 0. Okay, this is the properties of XOR operator. If we have something like this A XOR 0, then it will be result in A. Okay, this is 0, not O. We can solve this problem using the concept of XOR operator. Now what we will do, we'll iterate the array from left to right and we'll apply the XOR operator for all the elements, something like this. First we have 2, so 2 XOR 2, and then we will have 1. So 2 XOR 2, it result in 0. Okay, so we get here 0 XOR 1. So we get here 0 XOR 1, 0 XOR 1 equals to 1. This is the element that appears only once in the array. So we have to return this element. Now let's assume we're given this array of integers. Now let's apply XOR operations in between all the numbers in the given array. So we have 4 XOR 1, 4 XOR 1, XOR 2, XOR 1, then XOR 2. Now we see in here we have 2 1. So 1 1, it will be evaluated 0. And we have here 2 2, it will be evaluated 0. So 4 0, for this 2 it will be evaluated 0. Then XOR 0. Okay, now for this 2, this 0 comes from this. Okay, for this 2 and 2. Now 0 XOR 0 is 0. So 4 XOR 0. 4 XOR 0 equals to 4. This is the answer, and this element appears only once in the given array. So this is the single element or single number in the given array. This is the answer. This algorithm will take O of n time complexity, since we have to traverse the array from left to right, and it will take big O of 1 space complexity, since we're using just one variable. Now let's see how to implement this algorithm. Now let's implement this algorithm. First, let's create a variable answer equals to the first element. Okay, the first element. If we're given this array 4 1 2 1 2, we have answer equals to first element. That means 4. Now we have to iterate the array from the second index. So for int I equals to 1, I less than nums dot length I plus plus. Now here we have to apply the XOR operations in between all the numbers. Okay, so answer equals to answer XOR nums I, and at the end if we return the answer, we will have the answer in this answer variable. How it will works, Initially we have answer equals to 4. Then if we apply this for loop, then we get 4 XOR 1 XOR 2 XOR 1 XOR 2. So here this 2 and this 2 will be evaluated 0. So we have 0. If we apply here 0 and 1, we will have the result 1. Then the XOR in between 1 and 1 is 0. We know the XOR operations in between same number result in 0. So the XOR operation in between 4 and 0 is 4. And this is our single number in this array. That means this number appears only once. This algorithm will take big O of n time complexity and it will take big O of 1 space complexity, because we're using just one variable answer. Now let's run this code. It's accepted. Now let's submit it. We solved this problem maintaining the constraint, linear time and constant space. Thanks for watching this video. I will see you in the next video.